Next we will go for manually fabricating a PCB. So now you consider this LED power circuit. So we have previously seen one circuit, so that is a simple circuit. Before that, this is the original circuit where 230 volt AC is applied to this connector. It is a jumper connector. So this transformer steps down to 909 volt. So here 9 volt 0 and 9 volt will be received in the secondary side. So this could be there is a full wave rectifier is used and capacitor filter is used, so that you will get a 9 volt DC in this line. So next, this 9 volt DC with the help of this switch, if this is connected to the 3 number 3, then this AC circuit will power that is connected to the LEDs and power up the LED. Otherwise, this switch, if you connect the switch to the connection 1, then this will be disconnected and the circuit LED circuit will be connected from the battery. It will be powered from the battery. So this is a simple circuit to power up two LEDs. So we have designed for 9 volts and we have shown the calculation in the previous part itself to select the resistor value. Right. Now we will reduce a few components when we go for fabrication. As of now, to learn what is fabrication, we will not make it complex. So we will reduce few parts where transformers are what to say, we find difficult to place on a PCB. As of now, we will not go for that. So we will start a connector here itself and we will remove a few other components, the switches and other components which are not required as of now. See the simple circuit here, directly 9 volt AC, that is the transformer is separated, removed from here. Only 9 volt AC is applied to the diode and the switch is also removed. As of now, we are not going to use this. So battery is directly connected to this circuit. Okay, so we are going to fabricate these connections only. So this is as you have seen the previous schematic part, we have to convert it into the layout, right? So how to convert into the layout? Manually we will convert. See how it looks like. So this is the top side figure is the circuit diagram. The same circuit diagram I have drawn here. This one I have drawn here. This is hand drawn circuit and hand drawn layout. See, this layout should be drawn on the bottom side of the board, so it should be in a mirrored fashion, mirror image of the circuit. See how it looks like. This 9 volt starts here, right? If you mirror this, what happens when you mirror this image? 9 volt comes to the right hand side, and next as the diode D1 and D2, so it comes next to this 9 volt AC. D1 and D2 comes in the reverse direction. Next to this, see there is a connection here, this connection, and next comes the battery. See the battery connection is left, plus and minus connections are left here. Next to that, resistor connections are given. Next to resistor, LED1 and LED2 connections are given. So this should be the way you are going to draw a layout if you wanted to draw manually. But if you are using a tool, it automatically it takes it like that. So when you design it automatically, it will design the layout in the mirrored fashion only. So when you take it as a bottom layer, so that doesn't matter now when you draw it manually, you have to follow this method. Okay, now this is the layout. We are going to draw this layout in a copper clad laminate. What is that copper clad laminate? Let's see in the next one. See, this is the etching part. So after drawing this layout on the board with the help of the marker pen, see, draw in this fashion. So starting from the AC, there are diode options here, then battery option here, and then the resistor and diodes, LEDs. It is in a mirrored fashion as drawn as it is, and the other copper areas, it is a plain copper board. So except these areas, the copper should be removed from other areas. This copper should be removed. So what we have to do, we have to place this board in a ferrous chloride solution. Okay, So what happens, you have to give proper agitation, so that after 15 to 20 minutes what happens gradually we will see in the next coming slides. See how it is removing the copper. This area coppers are removed. Again gradually you see the next. It takes some time. So next after some time what happens? See, it is almost fully removed. After this what you have to do, you have to remove the board from that. Take the board out and clean this using the thinner. You have a thinner solution. Clean this marker ink using a thinner and wash with water. After washing with water, dry the board or wipe with a dry cloth. Okay. So next what happens? It looks like this. See, all the other parts are etched out. Only copper area looks like this. Only wherever connection is required, copper area remaining is there. The other areas copper is removed. Okay, now what you have to do, next process is drilling. Wherever you need to place the components, you have to drill. So you have a manual drill, you can use a manual drill here because it is a simple circuit, you can do it. So after drilling, it is not completely completed now, but a few 3 drills are done. Now it is shown. See, as per the layout, it is shown here. So the drilling is done. We will go to the next part. See, after all the component places are drilled out, and this is the top side. So actually this is the bottom side, and if you see from the top side, you can draw this circuit as it is for ease of connections. So when you assemble the components, which component how to connect, so if you draw the circuit like this, it will be easy for you to assemble. See, after assembling, how it looks like. See this 9 volt AC is should be given here in the from the bottom side. The soldering should be done from the other side. This is the top side of the board. So as I told you, the silk screen is the marking of the components. So you can say this is a silk screen. There is a D1, D2, 9 volt AC. These are all markings should be done on the top side. Okay. So these connections are like this, and next after assembling the components, now you see the bottom side. Say how it has been soldered. This is the top side. Bottom side should be soldered, right? So how it has been soldered. See, the component pins are connected, soldered, and above the copper, see, full and full solder lead material is applied. Why it is applied like this? Because if you leave the bare copper, see here, the bare copper as it is, easily and quickly it will get oxidized and corrosion occurs. To prevent this copper material from corrosion, either you should use a solder mask. So solder masking is an automatic process and it is a huge costly process. You cannot do it here manually. So we are what we are doing is we are applying the solder lead here. So it will protect the copper from oxidizing. So that is why it is applied like this. And the wire is also connected here. The battery is connected. So next, see the final working of the circuit. It's simple. A battery is connected, the LED is glowing. So how to select a resistor value, that calculation we have seen in the previous part. So this is the this you can use this video to learn how to do a small calculation and how to fabricate a simple circuit. Hope this will be useful for you, and this will be a very good motivator for you to learn these concepts in depth in future. All the best. Thank you.